What else is on the menu?
This is TATTAS. But I don't know, there's something kind of different about it. We left it unintended for a while, and it looks like the rodents got to it. Ate most of the electronic components inside. Man, that's a shame. There was a lot wrong with this amp. Some of which was listed in the video about it. Some of the stuff we didn't go into any detail about or didn't even mention. I mean, it wasn't a complete failure. We learned all sorts of stuff from it, even if most of them were from something not turning out right. But now that the rodents have eaten most of the electronic components, it looks like we have no choice but to rebuild it completely. So this is the schematics for the TATTAS as it was finished in the video that was released about it. Not the schematic I showed in that video that doesn't include the edits that we made. We got two full wave bridge rectifiers going on in here, and this one down here is totally pointless because it's 12 volts AC coming into this one, and both of the tubes run on 12 volts. So what do you think we do? Rectify the 12 volts AC into like 18 volts DC in this capacitor, run it through this 10 ohm resistor, which drops like 5 volts off of it, and then it goes into the tubes. So you got a bunch of waste heat dissipated in that resistor. Then up here we got two power supply transformers. You can select between them with the switch here. That was only because the power supply transformer that we used, we didn't test first and it didn't turn out to be very good. We got a 22 microfarad cap and then a 1K resistor and another 22 microfarad, and that goes to the main B+ line that powers the entire amp, except the boost input high gain stage. 100K bleed resistor across the little capacitor here that's only there to drop the voltage below the rating of the capacitors. More waste. Then a 300,000 ohm drop-in resistor here, internodal resistor to the B+2, which only powers this triode for the high gain input, nothing else. So, in light of the schematic being more wrong than right, we just start over. Since the 12BH7 turned out to be kind of a lousy output tube and an even lousier input tube, decided to ditch that idea and go with this Svetlana 6P1P. You can just barely see it there. See the little Russian P's? This is from Ukraine. It's a Svetlana tube, and it's the Russian equivalent of a 6AQ5, which is the equivalent of a 6V6. But the 6P1P is a 9-pin tube, not a 7-pin, which is very convenient because the TATTAS amp has 9-pin tube sockets on it. For the preamp tube, I'm going to use a 12AU7. It doesn't have very much gain, and I don't care about that. This is just going to be a, you know, a clean amp, I guess. And I have a bunch of these, so I might as well use them for something. Here's the new schematic I'm going to use. And I'm not going to amend the shit out of it and not show the amended version at the end of the video this time. For the filament circuits, we ditched the rectifier and just going to feed AC. Virtual center tap here for the, you know, the thing. And since the 12AU7 pulls a lot less current than the 6P1P, and I want to run them in series because I got 12 volts available and they can both be wired for 6 volts, I'm going to put a 33 ohm resistor here, parallel to the 12AU7, which will equalize the voltage across the two tubes. We got a more sensible power supply over here too. Now gone are the multiple power transformers. We're just going to use the original transformer that didn't work in the original attempt and just make it work. We got just a normal basic filter section like any old generic tube amp would have. And same story up here. This is like a Fender Princeton, but with different tubes, kind of, you know? Normal output transformer instead of that retardation. So, I've gone ahead and removed the rest of the components that the rodents didn't eat, except for the high voltage bridge rectifier over here. The rest of the parts are gone. That's a little weird. Yeah, how about that? So we're sitting at 363 volts with no capacitor out of that rectifier there. 362. Alright, that don't seem bad. Cap's rated at 450. And with capacitors, 788 volts. 790. That's a lot, bro. See why we had to do those stupid things with the power supply before now. Well, we can't exactly run a 6P 1P off of 800 volts. Did away with the little resistors here, and now the voltage is just out of control.
So where she goes? Well, I guess we're going the fuck on then.
So I've got it on the 100 volt tap now. This is power supply transformer for a tuner, and it was supposed to run off of 100 and 110 and 120 and 220 and 240 volts, right? I've got it on the 100 volt from brown to red there. It's the lowest voltage output it's got, I think. And it runs 173 volts. Also, if I let it run for a long time, the transformer will get very hot. And that's because it's getting too much voltage into its secondary primary coil, and it's not really able to keep running like that. With 3 of these NTC thermistors in series, with the secondary coil of the second power transformer, at 113 volts. I mean, it's climbing a little bit as the resistors heat up, but it's not 170 anymore. That might possibly keep the transformer from melting itself. You got 300 volts AC now on the secondary that we had been using. And in this configuration, between the blue wire and the red wire, our capacitor charges up to 320 volts with no load. Of course, it's gradually increasing, but we don't care about that. At 50,000 ohms across the capacitor, thermistors are nice and hot. And we're sitting at 233.3 volts. Maximum plate voltage is 250, and it doesn't say on here what the approximate plate resistance of the tube is, but when we look on the 6v6 data sheet, which it's supposed to be the equivalent of, we look at the plate resistance, and we got about 50,000 ohms at 250 volts, meaning that this is a fair assumption of what our plate voltage will be once the tube is conducting. So the power supply section's all redone now. I got a toggle switch on the front and some wires sticking out for an indicator light. Maybe we'll just leave it like that forever. And on the back where the stupid power switch used to be, now I got a IOFC connector, and it looks like it was supposed to be there. Man, you can't argue with that. Turns out the filaments were running at 7 volts each, so I stuck an NTC thermistor in between them, and now they run at 6 point something. And those 3 100 ohm resistors in parallel won't burn up as long as you don't take out the preamp tube, and if you do it, they will burn up. Ended up soldering the audio output transformer to the chassis because it was impossible to put screws through where I ended up wanting to mount it. And there's no other place to mount it because this amp is a game of Tetris. So there's the amplification circuits installed, except for the wires, the shielded cables, and I need to figure out somewhere to mount the orange juicer. Well, there's the shielded cables. Man, that connections on the back of that volume pot were tricky, but yeah, it's all done now, so I guess I can test it. Well, shit, we're only running 114 volts on the plate. Maybe our fair assumption wasn't that fair after all. Big surprise. So we're dissipating about 1 watt in the output tube. I'd say we're running a little under power. I switched it over to the higher voltage tap that I had originally been using, you know, the one that overcharges the capacitors and makes them explode. So we'll test it again with that. I don't know if you noticed earlier, but I had wired that backwards, so I also fixed that and test it again. Man, this thing takes forever to warm up with these thermistors in it. Man, that 50,000 ohms didn't mean shit. That tube has way less than 50,000 ohms of effective resistance, or whatever fancy engineering terms you want to use to describe it. So it takes about 5 minutes for this thing to actually warm up, thanks to these thermistors. Which, yeah, it more than ramps up the voltage slowly, that's for damn sure. I'll come back in about 15 minutes, and if nothing's on fire, I'll figure out what the bias is. Man, that's abysmal. 1 watt of plate dissipation. And here's how she sounds through the shop speaker. Man, it's not bad. It's got some crazy breakup thanks to that underpower situation. I guess the tone control has some effect, maybe. I'm not really sure. Yeah. Let's take our multimeter off of it. Remember what happened with the PV. So. Hi, Dan. Hi. Oh, what does it sound like in the intended speaker? Dude, this amp has no noise floor whatsoever, man. Nothing. Yeah, maxed out over here. The guitar's hooked up to it. The Squier 6 that has a buzz to it. Not a damn thing. All the brightness in the world when you got it turned for that. You get your nice muffled sound if you set it like this. We got Jacob Collins and Sarah kissing behind it. Yeah, I'm impressed. Well, in my little voltage increase attempt, I left this garbage, so I think I'll just heat shrink that up. And at least I'll solder that thing in properly, even though it's drastically oversized. Whatever, it doesn't matter. None of this matters. Just say Smith at Jones or something. About this faceplate situation. I don't want to leave it like this. So I got this cool idea. I'll just slap this little custom-made faceplate over the top of the existing faceplate. That should work. What do you think about that? That looks much better. See, now it doesn't have any unnecessary holes and shit. And look at how neatly the text came out. Printed by a computer, obviously. Now we can put it together. That's what I'm talking about. Yeah, that looks cool. Ain't got no tubes in it yet. There's the back. Don't know what I'm gonna screw it together with though. Kind of stole all the screws and their little decorative washers. Putting this thing together. So, how about some drywall screws? and some screws that we stole out of the third act.
You can blow me anytime.
That LED is way too fucking bright. Well, now that it's after the audio demonstration, nobody's watching anymore, we can finally pause the annoying background stuff that was drowning it out. Man, I'm impressed with the way this turned out. I thought after I saw those voltage readings that it was going to be a piece of shit. And as it turns out, it sounds pretty good, man. It sounds way better than the first TATTA. This is TATTA 2, the second TATTA. TATTA's 2.0. I have no idea how long it's going to last. It kind of smells like overheated resistor, slightly. But when it fails, we'll make a follow-up video and we'll talk all about it then. There isn't really any ranting to do about the data sheet and the output transformer and all that garbage like we wasted like 5 minutes on, being all serious, in the previous video about this amp. And since we know a little bit more about building tube amps than we did then, we're not going to have that obnoxious, pretentious, uneducated tone of voice that we had in that one either. So it's not going to be nearly as cool. But as promised, here is the updated schematic. We didn't make that many changes to it this time around. We got 3 NTC thermistors here and 1 here. Both of the coupling capacitors are 47 nanofarads now. The first filter capacitor is 47 microfarads. I've changed that to nanofarads instead of K. I don't know why I put a K before. And I changed the question marks. It's a 10K screen resistor and a 506 bias resistor. If you build one of these amps and you don't use the garbagey power supply that I used, it's going to be different than this. And the chances of you having the exact power supply that I used for this is next to nothing. The audio output transformer. In the last one, we used some crap like this. Well, not this exact one, this is out of the Teeny Tube Blaster, but, you know, more like this. And these are power transformers, and they have a solid core, and they have more windings than they're supposed to have, and they're separated and some other things, and they're not very good for an audio output transformer. And even though we had the impedance correct, and I made a major point to let you know that we had the impedance correct, 18,000 ohms, or 25,000 ohms, depending on how you look at it, because, you know, sum of impedance and resistance is inductance or something like that. This one is out of an MR10 or MR33 or something like that monitor radio, and it had a 6AQ5 output tube. It has a primary resistance of 5,000 ohms with a 3.2 ohm speaker, and we're running a 4 ohm speaker, so it's going to have like a little more than that, like, I don't know, 6,000 ohms or something. And that's perfectly fine for a 6P1P that's running at its proper voltage, which this ain't. So who knows, man, all bets are off if this thing's working right. But this one's kind of unique. It was more unique last time, I think, than this time, but it was a lot worse off, you know. If you didn't see that video and you don't feel like going back and watching it, here's the list of things that I said in that video. We have reduced the power output by 40 times. The amp also now squeals and has an audible hum under some conditions. And the overdrive channel is very muffled, has poor frequency response, has unpleasant sounding distortion under about half of the conditions that it could encounter. The clean channel has about half as much overdrive as you would want out of an overdrive channel. The words volume and tone aren't in shadow. They're just kind of translucent. Put them on there half-ass and then clear coated it. So now they're stuck forever. And the faceplate that I stuck on is kind of crooked. You see that? It's gonna drive you nuts. Slightly crooked. I may or may not eventually fix that. I don't know. It's gonna depend on whether it bothers me enough. Well, I mentioned that we stole these screws out of the third act. Well, the third act ain't looking so hot these days. But we'll cover that in some upcoming video. Now be sure and go